Hello class, this is lesson 19.2, surface area of prisms and cylinders. So now we're in the chapter that talks about surface areas. The previous chapter talked about volumes. And going forward, we're going to be talking about surface area of different objects. So let's start by the definition of a surface area. The surface area is the total area of all the faces and curved surfaces of a three-dimensional figure. So imagine you have a box and you unfold it. What we want to do is we want to find the area of each side of the box. Or imagine if you have a basketball and you want to gift wrap it. So imagine that you're trying to find the area of how much wrapping paper you need around the basketball. That's what these formulas are going to give us. So with the first example, we're trying to figure out again surface area and trying to explain surface area. In an object, we have something called a lateral area, which is the sum of the object. It's the sum of the areas of the object, not including the base. So imagine that you have this object. So this is a rectangular prism, but imagine that we unfold it to look like this. So think of a box. A box has 6 sides. So 1, 2, 3, 4, 5, 6. The lateral area are the sides of the box. So all of these. This is the lateral area. And the top and bottom of the box are called the base area. So the base area and then the base area. So what we do is use capital L to talk about lateral area, and then we use capital B to talk about base area, which kind of explains it here. So if you want to find the area of the lateral area here, we need to find the area of each piece, or what we could do is find the length of this times it by the width. Now the length of these 4 pieces, so this is 12, 9, 12, 9, and this is 30, you end up with 42 times 30, which is 1,260. And then if we look at the base area, so to find the area of just this piece and this piece, this is 9 times 12 for the bottom, and then 9 times 12 for the top. 9 times 12 is 108. So we have 108 and 108. So if you wanted to find the surface area of this entire object, you would add the lateral area plus the bottom base plus the top base. Now we're going to be using a simpler formula going forward, but this is just explaining what we're trying to do in this lesson. Okay, so here we have a triangular prism and a net of a triangular prism. So a net is where we take this prism apart into pieces, and notice that we have different pieces of this prism. So this piece is the side face. So this side face right here. This piece is the bottom face. This piece is the left face, and then these are the bases. Okay, so now let's look at that formula to find surface area of a rectangular prism. And that is this main formula here. So, to find the surface area, we need to find out what the perimeter of the base is times the height plus 2 times the area of the base. So we're going to be using this formula in the next examples. And we're going to be doing this in steps. So the first step is to find the lateral area, which is the perimeter times the height, the perimeter of the base times the height. So let's focus on step 1. Step 1 focuses on finding the perimeter of this rectangle. So let me draw it out here. So we have 8, 6, 8, 6. If you were to add up all the sides, that gives you the perimeter, which ends up being 28. Now the height of the object is 12, so that's why we use 28 times 12. The perimeter of the base times the height is 336. Next, we need to find out what B, area of the base, is. Now, to find the area, we multiply a length times the width. 8 times 6 is 48. So now that we have the lateral area, now that we have the area of the base, we can use this final formula. 336 plus 2 times the area of the base, 2 times 48, is 336 plus 96, and that is 432. So if you're still having trouble with this, we'll take our time with this next example. So in this next example, the gift box is a right prism. Find the total amount of paper needed to wrap the box. Do not count overlap. So there's a couple things that we're going to need to find out first. What is P? What is H? And what is B? What is the perimeter of the base? What is the height of the object? And what is the area of the base? And to help me out, I'm going to just focus on the base, drawing a rectangle. The length is 18, the width is 5. So to find the perimeter, we add up all of this. So we're going to have 18 plus 5 plus 18 plus 5. So 18 plus 18 is 36. 36 plus 5 is 41. 41 plus 5 is 46. So this is equal to 46. Now the height of the object is 5. Then to find the base, we're going to multiply the length times the width of the base. So 18 times 5 ends up being 90. So now my formula so the perimeter times the height plus 2 times the base. So what I have is 46 times 5 plus 2 times 90. 46 times 5 is 230. 2 times 90 is 180. 230 plus 180 is 410. So this would be 410 cubic or squared inches. So find the perimeter, find the height, find the base, plug it in, and solve. Okay, next we're going to talk about how to find the surface area of a triangular prism, which is similar to finding the surface area of a regular prism, but the only difference is the base that we are using are the triangles. So keep that in mind. So there's 4 steps. Find the leg or hypotenuse if it's not given. Find the lateral area. So find the perimeter times the height. Find the base, and then find the total surface area. So for step 1, remember that we want to find the perimeter of the base. And because the base is the triangle, so let me kind of draw this triangle. This is 24, this is 10. We need to know what this side is. Because to find the perimeter of the triangle, I need to know all 3 sides. And that's what this Pythagorean theorem is going to give us. So if I call this C, 24 squared plus 10 squared equals C squared. C ends up being 26. So now that I know that this piece is 26, now I can find the perimeter. The perimeter is 10 plus 24 plus 26. The height is 20. So the height of the object is 20. So now I end up with 1,200. Then to find the area of the base, so the area of this triangle is half of 10 times 24. And that's what this formula tells us. And that is 120. So now that I have everything, I could plug into this formula. 1,200 plus 2 times 120 ends up being 1,440 squared inches. So then next we're going to work on one example together. And to start on this example, I'm going to just draw a triangle to the side, because that's going to be our base. Now all of these triangles in these problems are going to be right triangles. So if we look at this triangle, this side is 3.6, this side is 6, but we don't know what this side is. So I'm just going to call this x. I could use the Pythagorean theorem to help us find this. So x squared plus 3.6 squared is equal to 6 squared. So if we find out 3.6 squared, I get 12.96. So this is x squared plus 12.96 equals 36. Subtract 12.96 to both sides, and you end up with x squared equals 23.04. And then we have to take the square root of that. And I get 4.8. So this piece is 4.8. Okay, so now that I know that, I could do the steps. So I could find the perimeter, I could find the height, and I could find the base. The perimeter is going to be 3.6 plus 6 plus 4.8. So 3.6 plus 6 plus 4.8 is 14.4. The height is 3.6. The height is 8.5, and then we need to find the area of the base. So to find the base, we're going to use the formula 1/2 little b times h. Now that is the area of a triangle formula. So the base of the triangle is 4.8. The height of the triangle is 3.6. So our formula would be 1/2 times 4.8 times 3.6. And if we do this on the calculator, so 1 times 4.8 times 3.6 divided by 2 ends up being 8.64. Or if I round out to the nearest tenth, it'll be 8.6. So that is what B is. So the area of the base. Area of the base is 8.6. The height of the object is 8.5, and the perimeter, the perimeter is 14.4. So to find the surface area, we have the perimeter, so 14.4 times the height times 8.5 plus 2 times the base. Two times 8.6. And typing all of this in the calculator, we get, 14.4 times 8.5 is 122.4. 2 times 8.6 is 17.2. And 17.2 plus 122.4 is 139.6 inches squared. So we started this problem by finding the base of a triangle because we needed that to find the perimeter of the triangle and to find the area of the triangle. Once we had that piece, then we were able to use the surface area formula, which is the perimeter of the base times the height of the object plus 2 times the area of the base. And we ended up with 139.6 inches squared. Okay, so we're going to move on to how to calculate the surface area of a cylinder. Now, what this diagram is trying to show us, we have the three-dimensional object of a cylinder here, and this is the net. So if I was to unwrap this cylinder, notice that we have a circle at the bottom, a circle at the top, and then this piece that's unrolled is this piece here. So this long piece is called the lateral area, and these circles are the base area. So notice that there are 2 base areas and 1 lateral area. So because we are dealing with circles, we need to use the radius of a circle, and then we also need to use pi. Our formula for the surface area of a cylinder would be 2 pi r h, so 2 pi r times h plus 2 pi r squared. Now if you're asking where we get this formula, This 2 pi r, that is the circumference of the cylinder. So that's the length. And this pi r squared, that is the area of a circle formula. The area of a circle is pi r squared. So pretty much to solve these problems, we need the radius and we need the height. In our first example, we are going to find the surface area of a cylinder in 3 steps. The first being finding the lateral area. Next, finding the area of the base. And then finding the total area of all faces of the cylinder. So to find the lateral area, we are using 2 pi r(h). The radius of this object is 2.5 because half of 5 is 2.5. And the height of the object is 2. So 2 pi times 2.5 times 2. And they also want this in terms of pi, so that's why you see 10 pi. So lateral area is 10 pi. Then to find the area of the base, we just need the radius. So pi times 2.5 squared ends up being 6.25 pi. Next, we're going to plug in our answers into the equation for surface area. So what we got for 2 pi r(h) was 10 pi. What we got for pi r squared was 6.25. So we see we have 10 pi plus 2 times 6.25 pi. And at the end of this, we end up with 22.5 pi inches squared. So we're going to be doing 2 examples similar to the example that we saw, and we're going to leave our answer in terms of pi. So that's important. We don't want to multiply 3.14. We just want to leave the pi alone. So when looking at this problem, I want you to identify 2 things. I want you to identify what the radius is and what the height is. The radius for problem number 1 is 6. The height is 15. So when you're writing your formula, the surface area is equal to 2 pi r(h) plus 2 pi r squared. So in those parentheses, I'm going to put the numbers that belong there. So the first number is the radius, 2 pi r. The radius is 6. Then this is the height. And then this is the radius, 6. So because we're ignoring the pi, we could just multiply these numbers. 6 times 15 is 90, and 90 times 2 is 180. So this ends up being S equals 180 pi. Now 6 squared is 36, times 2 is 72. So plus 72 pi. 180 plus 72 ends up being 252. So 252 pi centimeters squared is our surface area. Okay, for problem number 2, we have a similar situation. We need to identify what the radius and the height is. So the diameter of this object is 72, so the radius has to be half. Half of 72 is 36, and the height is 80. Same formula, different numbers. We're going to have S equals 2 pi RH, so 36 times 80, plus 2 pi r squared, and we're going to put in 36 there. Now I want to show you how to do this in the calculator. So again, we're ignoring the pi, so we can multiply 2 times 36 times 80. That ends up with 5,760 pi, and then 36 squared times 2 is 2,592 pi. And then when we add these two numbers, 2,592 plus 5,760 ends up being 8,352 pi millimeters squared. That is our surface area. Okay, next we are going to talk about composite figures. So how do we find the surface area of a composite figure? And remember that a composite figure is made up of different solids, so different shapes. And again, we're trying to find out the surface area of these shapes. Okay, so for this example that it's already done for us, what we want to do is we want to determine what the surface area is of the object. Now, in this problem, we have a rectangular prism, and what's occurring is that we are drilling into this rectangular prism so that we have a hollow piece in the middle in the shape of a cylinder. And the formula that we're going to use, or the setup for this problem, is to find the resulting surface area. We need to find the surface area of the entire prism. So find the surface area of the prism plus the lateral area of the cylinder. So because we're making a hole here, this piece, the lateral area of the cylinder, is exposed, minus the base areas. So again, we're not going to have a top piece or bottom piece, so we're going to be subtracting those from the total. Okay, so for step 2, finding the surface area of the prism. So the base of the prism is a rectangle, and to find the perimeter of the rectangle, you add 24 plus 16 plus 24 plus 16, and that's what ends up happening here. 80 is the result of finding the perimeter of the base. Okay, the height of the object is 20, and to find the base area, 24 times 16, and then we end up with this part here. So the surface area of the prism is 2,368, and we're going to leave that answer alone for now. The next part is finding the lateral area of the cylinder. So this cylinder has a radius of 4 and it has a height of, so radius of 4, height of 20. Let me zoom out. And that is what they are using for this part. To find the lateral area, we are using 2 pi RH, 2 pi times 4 times 20, and that ends up being 160 pi. Each base is, to find the area of the base is pi r squared. So what they're doing here is showing you that to find the area of the base of the cylinder, we have pi times 4 squared, which is 16 pi for each one. So for each base, That is 16 pi. This is 16 pi. And the resulting formula, again, is the total surface area, 2,368, plus the lateral area of the cylinder, minus 2 times the area of the bases. Ends up giving us 2,769.9. Now you guys might be thinking, how did they come up with that formula? You guys have to think about if this was a real object and you wanted to cover the outside edges. If you drill into this prism, all of the edges of the cylinder will be exposed, and the top and bottom of the cylinder will be removed. So it's like you are finding the entire surface area, but then adding the inner walls of the cylinder, but then you want to subtract these pieces because they are removed. So we're going to try a few problems together for finding the surface area of these composite figures. And we have a formula that we're going to use on some of them, which is, well, for the first one, we have the prism of the surface area plus the cylinder lateral area. Okay, let's start with the prism. So let me draw a rectangle, and imagine this rectangle is the base of this prism, and let's write the sides. So this is 9, this is 4, this is 9, and this is 4. How do we find the perimeter? We add up all the sides. So the perimeter is 9 plus 4 plus 9 plus 4. 9 plus 4 is 13, plus another 13 would be 26. Now the height of the object is 5, because we see it going up 5. So h is 5. And the base. How do we find the base? Remember, we multiply the length times the width of the base. So we're going to do 9 times 4, which is 36. So that information gives us everything we need to find the surface area of the prism. So we have S is equal to the perimeter times the height plus 2 times the base. So we have 26 times 5 plus 2 times 36 ends up being 202. So I'm going to circle that, and then I'm going to put that to the side. Next, I'm going to focus on the cylinder. But when looking at the cylinder, we do not want the surface area of the bottom or the top piece. Well, actually, let's think about it like this. This prism surface area is the entire prism, is the entire surface area of this here. But because this circle is being covered by this cylinder, we don't need to wrap this with any material. So imagine that we are just cutting this piece out and putting it on the top. So this formula, this number, gives us the surface area for all of the prism, all the edges of the prism, and the top of the cylinder. Because remember that we were cutting this piece and putting it to the top. What that means is that we only need to find the lateral area of the cylinder, and the lateral area of the cylinder is 2 pi r h. So what we need is the radius, which is 2, and the height, which is 3. This would be 2 pi times 2 times 3. So 2 times 3.14 times 2 times 3 is 37.7. Now what we need to do is just add these two together to find the total surface area. So S composite is equal to 202 plus 37.7, which is 239.7 centimeters squared. Okay, let's look at problem number 2. Similar to problem number 1, we find the surface area of the bottom and then find the pieces on top that we need to cover. So the bottom is a prism, and we could find the perimeter of the base, the height of the object, and the area of the base. So I'm going to write P, H, and B for this object. So the perimeter is 9 plus 7 plus 9 plus 7. And that is 16 plus 16, which is 32. The height of the object is 5. And the base is 9 times 7, which ends up being 63. So the surface area of this object is 32 times 5 plus 2 times 63. Perimeter times the height plus 2 times the base. So 32 times 5 plus 2 times 63 gives me 286. So I'm going to keep that answer and hold that answer and while we look at the other object. Now I do want to mention though that similar to problem number 1, this surface area covers the bottom prism, and because we don't need the surface area of this bottom piece, imagine that we cut this rectangle and cover the top with it. So we don't need the bottom, and we already have the top from this number. So pretty much all we really need to do is cover the sides of the top prism. And to cover the sides, all we need is to find the lateral area of the top. So I'm putting L top, which stands for lateral area of the top, and the formula again is the perimeter of the base times the height. So if we look at this rectangle, what is the perimeter of this rectangle? We have 3 by 5, so this has to be 3 and this has to be 5. And the height of this object is 3. So my perimeter would be 3 plus 5 plus 3 plus 5, and my height is 3. And 3 plus 5 is 8, double that, we have 16, and 16 times 3, so let me write 16 times 3, ends up being 48. So we have 286 plus 48, and the surface area would be 286 plus 48, and that is 334. Okay, last example is 2 cylinders. So imagine we have a cylinder and we drill into it. So what happens is we don't have a top piece, we don't have a bottom piece, and we only need to find the lateral area of the inner cylinder. So we start by finding the lateral area of the outer cylinder. I'm sorry, the surface area of the outer cylinder. So I'm going to put S outer, and remember the formula for surface area of a cylinder is 2 pi r h plus 2 pi r squared. So the radius of the large cylinder is 7, the height is 6. So we have 2 pi times 7 times 6 plus 2 pi times 7 squared. Now I'm going to leave this in terms of pi, so all I'm going to be doing is multiplying the numbers. 2 times 7 times 6 plus 2 times 7 squared ends up being 182 pi. So next we have to find the lateral area of the cylinder. So I'm going to put L of the inner cylinder is 2 pi r h, and the radius of the inner cylinder is 3, the height is still 6. So we have 2 pi times 3 times 6. 3 times 6 is 18, and 18 times 2 is 36. So we end up with 36 pi. Okay. Now, because I am removing the bottom circle and the top circle, because remember I'm drilling this, I need to subtract the area. So I need to find out the base of the inner, which the formula we're going to use is pi r squared. So I'm just finding the area of the circle, and the radius is 3, so this is pi times 3 squared, which ends up being 9 pi. So the way we're going to be doing this is we're going to have the outer plus the inner minus 2 times the base, the inner base. So let me write it here. S outer plus the lateral area of the inner cylinder minus 2 times the area of the base of the inner. So let me move this a little bit higher, and then I'm just going to write here. I'm going to have 182 pi plus 36 pi minus 2 times 19 pi. So we do 182 plus 36 plus 2, sorry, I made a mistake here, 2 times 9. That's 2 times 9. This ends up being, I'll write it here, 236 pi millimeters squared. So the surface area is 236 pi millimeters squared. So I think that was one of the more complicated problems, because we kind of have to visualize us actually wrapping an entire object, and if we drill into an object, we remove the top and bottom of that drill, but we already accounted for that for the first surface area, and that's why we're subtracting those bases. Okay, so that pretty much completes lesson 19.2, which was the introduction of surface area for prisms and cylinders. Complete the homework below. Find the surface area for each. And as a hint, I always like to write these three. So find the perimeter of the base, find the height of the object, and find the area of the base. And then plug in those values into the formula. After you finish 19.2 homework, you will be given the 19.2 checkpoint and find the surface area of these figures. And that completes this lesson. Have a good day, guys.